So my question to you, Sharath, is may seem a little trivial at this point, but nevertheless, rather than asking you once again the what of that question, my question is, what is it that you have done with reference to the various projects, not just specifically to, with reference to the fuel efficiency model that you've done, but various other projects. What are the care that you have taken for the purpose of feature selection specific to that? Definition, I think we are beyond that, but your experiences, please.
Yeah, thank you for that question. Like Mr. Bunny has already mentioned, ultimately we have to choose the right or appropriate features into our model building, and the decision, this process starts right from the step one, where we get the access to the business problem. Now, when we want to decide the features that we are going to choose, a lot of insights have to come from the subject matter experts. Unless until you understand the domain, it might not make sense for us to blindly choose some random variables and then try to build a model. So domain analytics or your domain knowledge is going to be pivotal. Then talking to your subject matter experts, you will be able to define certain variables which actually allow us to shortlist those features. This is from a subject-wise, right, business-wise. But once we get the business-related features, once we shortlist them, we might also want to check whether the data that these columns have, these features have, actually some meaningful sense. And right, we also try to define whether the relation between the variable of interest and the features that we are taking are actually having some kind of a pattern and relationship. From that perspective, we also have to do the correlation checks, the feature important plots that Barney was also speaking about in our last session. Using decision tree concept, we can do that. In random forest, we have feature plot as well, feature importance plot. And manual, anyways, we talked about. We also look into the forward feature selection, the AIC-based techniques, which can also allow us to identify the features that we are going to shortlist, which are going to give us good results. So these are some of the points that we will have to take care of course, depending on whether the values are the features that we're considering are numeric or non-numeric. Of course, when the values are numeric, we will have a lot of techniques, statistical techniques that we can use. From non-numeric perspective, of course, we will have to try and look into the relationship, and we can also use the information gain concept from the decision trees, which can help us to identify which features contain more information with respect to the variable of interest that we are trying to build the model for.
Yeah, so like I said, these are the topics which excite a data scientist, and there's something I'd like to add on with reference to feature selection. There is a simple rule of the thumb, all right? And the rule of the thumb is that the database which you get, ideally should be in such a way that the most important column or the feature is on the left extreme, and the least important column is in the right extreme. That is how it is ideally expected. So if you are receiving a database from a person or subject matter expert, or if you are even collecting the data, please identify, rank those columns 1, 2, 3, 4, which is 1, the left extreme. So if you are in short of time, that itself can be a very simple feature selection. I'll take the first and I'll take the first 20. This is again for the shortcut method. I just wanted to, share it with you. So yeah, Barney, regarding your insights with feature selection, quickly, any interesting anecdote that you have?
Yeah, Nitin. So with respect to feature selection, I would say the first and foremost thing is you will have to gain sufficient domain knowledge to proceed further. as a data scientist, when you join different companies, be it Infosys or TCS or Wipro or any of the service providers, uh, or for that case, any of the Mang companies like Meta, Amazon, Apple, etc. You might be given, for instance, if you join Amazon as a data scientist, you might be given a project in the space of procurement fraud detection. Now, you are expected to gain sufficient domain knowledge in the space of procurement management. There are a lot of research forums which are available. One classic thing that I would always recommend is to go to Google Scholar and then do a search, procurement fraud machine learning models, for instance. A few are paid. Of course, you need to spend some money. Usually analytics and advanced analytics startups, as well as the mature companies, will have access to these kind of research forums. And you will have to do a quick research to understand what are the variables which are used in terms of prediction, to predict what are the various variables or features which were used. Do you have those kind of features in your model or not? Is something that you need to look at. And look at 4 or 5 different models, 4 or 5 different projects which were accomplished. Look at all the features, and the features which are used in majority of the models are probably the first set of things which you need to have in your model. When you build a model in your data set, those have to be there. Okay, this is one side of the story. And always try to normalize the data. What do I mean by normalizing the data? If you have, for example, total debt, as in the project loan default prediction model, we had something called as total debt. It can be normalized only when you know what is the total income. When you divide the total debt by total income, you get a new feature, which is normalized feature. And of late, there is huge preference which is given to these kind of models wherein you normalize the features. Okay. Yep. So it's again, if the question is around which feature selection technique is better, it's something like, you're asking a question on, do I need to book a cab using Rapido or using Ola or using Uber? Or it's probably a kind of question wherein, which laptop is better? Should I go with Lenovo or Asus, or do I need to go with some other laptop, right? So answer would be the same always. And once in one single word, if I were to say, you need to experiment, right? Experimentation is the only answer to the questions which surround what techniques make more sense. What techniques do I need to use? Thank you.
Thank you, Bernie. Thank you. And I see that you have quickly answered one of the questions that one of our audience has posted in that thing itself. Thank you so much for that response there. So yeah, let's quickly continue. So we've
Nitin, if I may just interrupt.
Yeah.
Sharad, that link that we have pertaining to the mind map, can we have someone post it on the YouTube chat here? Because there are questions. Samyukta is asking a question, so we can probably post and then people can benefit. I think it makes more sense to have our experts posted, digital marketing experts posted on a LinkedIn profile so that they may pick it from there.
Yeah. So, all right. So I have a next question here, and I'd like to, quickly, I'm going to ask this to Bernie once again, because we have worked on something and I'm expecting him to answer on those lines. So with reference to feature cleansing, because data cleansing, yes, we have done that. But with reference to feature cleansing, what is that subtle difference between the two? Could you please, explain for the benefit of our audience?
Yeah. So Nitin, it actually means the same. Because when you look at the data, your data might contain your features, which are usually your input variables, and labels, which are usually your output variables, right? So you don't usually meddle with respect to feature construction, etc., when it comes to your output variable, and you usually deal with your features. And hence it's called as feature, cleansing, or dealing with your features is actually dealing with your input variables. Given that it's a supervised learning model, if it's unsupervised learning model, then both data cleansing and feature cleansing would actually mean the same.
Thank you so much. Thank you so much. So let us now quickly discuss about, why we need to do the transformation. All right, engineering, we have done doing some combinations, but what about transformation? So Sharath, could you please throw some light on the purpose of feature transformation?
Yes, yes, Nitin. So when we talk about feature transformations, the word transformation itself has, I should say, multiple meanings. One of the first and foremost meaning that we need to consider is with respect to the distribution of the data. And ideally, it should fall under the so-called normal distribution. It should not have any exceptional cases when you're trying to deal with the data. So from that perspective, in analytics, we try to manipulate the data. You can say it's like, right, on a jovial note, we cheat the data and say that, hey, we kind of change your magnitude so that you don't show that exceptional case. This is one way to look at when we talk about transformations. So this is simply like managing or altering the magnitude of the data so that we achieve the normality constraint that is required. Now coming to the feature transformation, this is of course very similar to what we're talking about. Maybe want to change the definition of the column or the feature that you have. For example, say for instance, I was working on the data with respect to automobile industry. And here I had data with respect to, let's say, weight or the fuel efficiency itself, if I talk about. It was captured in miles per, let's say, the gallon of fuel. Now, in order to make it more readable and more easy to interpret, we converted that into kilometers per liter. Right? That's a feature transformation. The entire value was kind of altered from one unit, one form of units to another form of unit. Right? So this is feature transformation in a way to explain with example.
I see, Barney, you are, I can make out from your expression, there's something you want to add with reference to with so many years of interaction, I'm able to read your expression. So what would you like to add with reference to feature transformation specifically?
Yeah. So feature transformation is all about changing the latent structure of the data. Latent means hidden structure of your data, basically. If you're given a specific variable or a feature, and if you do a log transformation or reciprocal or Box-Cox or Johnson, anything of that kind, you're changing the underlying nature of the data. Okay. And once again, there are a few techniques which can be used for both feature selection as well as feature transformation. And one such example is principal component analysis. Right. And what principal component analysis does is it will take your original features or original variables, and then it would do some math operation on that. That is exactly what feature transformation does. You apply log or exponential or reciprocal or cube root or square root or whatever you want to do. Basically, it will apply some math application on that. It will apply some formula onto the original features. And then it will ensure that it transforms the data into a new data altogether. For example, if I have two columns, and if I feel that age and income are correlated, then when I apply a principal component analysis on that, I'll get new variables altogether, which will be uncorrelated. And certain algorithms, machine learning algorithms such as linear regression, etc., expect your variables to be uncorrelated, your features to be uncorrelated. Given that, we can use certain algorithms for multiple purposes as well. Yeah, thank you, Nitin.